We actively look for them by dissecting the atoms and molecules that comprise these mysterious worlds. The Webb telescope transforms our knowledge of what might exist beyond our blue dot by enabling us to turn our conjectures and speculations about alien worlds into methods to confirm or disprove them. It is more than just an eye in the sky. It is a highly specialized laboratory analyst and cosmic detective all in one. Scientists using the James Webb Space Telescope captured something extraordinary from Proxima b, a signal so unusual that it swept through the academic corridors and social networks. Labeled as a possible technosignature, it was actually an electromagnetic emission so complex and enormously patterned that it could indicate the existence of an advanced civilization. Just when you thought you had unwrapped the most sensational layers of this cosmic onion, the narrative takes an unexpected twist, just like in any science fiction thriller. The world's collective heartbeat seemed to stop at the height of an announcement that held the potential to fundamentally change the way we see the world. Could this signal be the indisputable evidence that we are not alone in the cosmos? Because as soon as it appeared, it vanished without repeating itself, leaving behind not only a deafening silence but also a tangle of unsolved mysteries and brewing theories. Was it just a passing cosmic event, an accident of cosmic alignment, or something more intentional like a coded message or even the apparition of an eerie cosmic essence? The solitary mission cast the shadow of enigma over Proxima b, sparking intense debate and speculation. Was it just a passing anomaly, or is it part of a cosmic narrative far more complex than we can imagine? But wait, the narrative tapestry of our cosmic exploration is not complete. The ink has not yet dried and new chapters are still being written. This time, it is not just ordinary scientists but Harvard researchers who are leading a paradigm shift in our search for extraterrestrial life. They are not content with just scrutinizing the signal and phenomena we have discussed so far. They're upping the game by transforming the James Webb Space Telescope into a sort of cosmic night vision telescope. Their goal is to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're talking about staggering implications such as the possibility of detecting terrestrial versions of cities glowing in the dark like luminescent oases. Imagine seeing the radiant poles of what could be a metropolis humming with the presence of an advanced civilization, radiating its luminescence into the vast cosmic oceans. Our pursuit of understanding the mysteries of the universe is motivated by both technological breakthroughs and a deep curiosity about our place in the cosmos. As we search farther into the vast unexplored regions of space, our quest for extraterrestrial life takes on new dimensions beyond the immediate intrigue of Proxima b. Numerous exoplanets with possible habitability have been found as a result of recent advancements in astronomy and space research. Ground-based observatories and tools like the James Webb Space Telescope (JWST) have increased our capacity to find and study these distant worlds. Finding biosignature indications of life is an especially fascinating area of research. Under some circumstances, atmospheric gases like carbon dioxide or methane may indicate biological processes. The JWST's capabilities go beyond simple recognition. By analyzing starlight that passes through an exoplanet's atmosphere, scientists can measure the atmospheric composition of exoplanets with unprecedented accuracy. They can also identify signs that may indicate the possibility of life, such as the presence of water vapor alongside other essential molecules like oxygen or ozone. Examining the climates of these far worlds through climate simulations is another line of inquiry. Water is thought to be a necessary component for life as we know it, so it's important to predict whether an exoplanet's conditions could support liquid water. Based on data from JWST, researchers are especially interested in planets located in the habitable zone of their parent stars, where temperatures might allow for stable liquid water. The search also includes exoplanet moons. Some of these moons, especially those in the habitable zones of their host planets, may have habitats that support life. For example, icy moons in our solar system like Europa and Enceladus are believed to have subsurface oceans beneath their icy crusts. Comparable moons around exoplanets might offer similar environments where life could conceivably exist. Moreover, the idea of technosignatures has gained traction. These are indicators of highly developed civilizations that may be found in man-made structures or technologies. Examples of such indicators include megastructures such as Dyson spheres, hypothetical structures meant to capture the energy of a star, or anomalous patterns in radio signals. As our observational techniques advance, the search for technosignatures may disclose the existence of extraterrestrial intelligence. International cooperation is essential to finding extraterrestrial life. Collaborations between private businesses, research institutes, and space agencies, for instance, improve our capacity to explore space. Contributions to expeditions to Mars and other celestial bodies come from several nations, combining resources and knowledge to accomplish shared objectives. Education and public participation are also important. The excitement surrounding space exploration and its crucial role in this quest serves as an inspiration for the next generation of scientists and engineers. In addition to encouraging young people to seek careers in space research, outreach activities and educational projects also help to deepen our understanding of the cosmos. Through the creation of new technology such as advances in telescope design, data processing and computational models, we enhance our capacity to find and examine far-off exoplanets. Future space telescopes like the Habitable Exoplanet Observatory (HABEX) and the Extremely Large Telescope (ELT) are planned. As we continue to push the limits of our knowledge, HABEX promises to provide even more in-depth observations and deeper insights into the possible habitability of exoplanets. Every discovery raises new questions and research fields. In summation, the hunt for extraterrestrial life expands our understanding of what it means to be alive and challenges our perceptions. It is not just about finding alien civilizations, it is also about learning about the beginnings and possible diversity of life in the cosmos. Exoplanet exploration and the hunt for extraterrestrial life are dynamic, ever-evolving fields that, with each new discovery, bring humanity one step closer to understanding some of the most important questions it has ever posed. As we continue to explore the cosmos, the possibilities for finding new life forms and comprehending our place in the universe remain endless. Don't forget to like and subscribe. Imagine an infinite number of stars, planets, and moons performing in perfect harmony to create a cosmic symphony. However, there is one particular portion of this orchestra that has baffled astronomers for ages. We explore the fascinating world of Proxima b, which is only 4.2 light-years away from Earth. The James Webb Space Telescope is revolutionizing our search for and understanding of these celestial mysteries. Exoplanets are natural planets that exist outside our solar system, hidden deep in the Milky Way. You might be surprised to learn that among the vast number of cosmic objects, there are exoplanets so similar to Earth, so tantalizingly similar but enigmatic, that they could be our planet's celestial twin. To put this figure in perspective, picture a moment in which your imagination travels over the immense celestial domain of our galaxy, the Milky Way, which is home to more than a quadrillion exoplanets, or 1 with 15 zeros. We would have enough exoplanets to fill the Grand Canyon and establish a new geological monument on Earth if each of them were the size of a grain of sand. The most astounding finding is that 20% of these celestial bodies have geological and atmospheric structures similar to Earth's. This implies that there is a 1 in 5 chance of discovering a planet that is identical to ours. And the story doesn't end there. There may be another quadrillion moons in addition to these planets. The universe is full of possibilities. If you were to think about the prospect of finding another body in space that harbors life, or might do so, rocky satellites like our moon are locked in gravitational dances with their home planets. Now that the cosmic canvas has been unrolled, let us present the skilled artist capable of illuminating all of its fine intricacies, the James Webb Space Telescope. This celestial Sherlock Holmes, which has telescopic lenses in place of its magnifying glass, performs better than even the most sophisticated modern optics. Its 6.5-meter primary mirrors are 2.7 times larger than Hubble's, so you can imagine the tiniest detail it can discern, even in the faintest flicker of a star billions of light-years away, and then analyze the details of planets in orbit. The James Webb Telescope is revolutionary, not just because of its superior observing capabilities, but also because of its cutting-edge technology, which includes spectrographs and forward sensors. These instruments are capable of much more than just observation. As a kind of space forensics, they can identify whether a planet contains oxygen, water, or organic compounds by analyzing and filtering the distinctive light signatures that celestial objects emit or reflect. The James Webb Space Telescope is more than just an improvement over its predecessor, Hubble. If you were surprised by Hubble's discoveries, get ready for a veritable feast of celestial revelations. It can answer these questions, transforming it from a mere observer to an analytical genius. In the same way that we have expanded our focus to include the vast and intricate universe, it is worthwhile to concentrate on one specific star, Proxima b. Since its discovery in 2016, this mysterious planet has distinguished itself as a Shakespearean protagonist, enthralling astronomers and anthropologists with its complexity and paradoxes. But first, what is all the hype about? Proxima b is essentially within our cosmic neighborhood, only 4.2 light-years away from Earth. To put it into perspective, if you could travel faster than light, you could reach your destination in just over 4 years. roughly the same amount of time it would take for your favorite TV show to end or a presidential term. But let's take a closer look at why this proximity is so significant. Since the universe is over 93 billion light-years in length, discovering a planet this close and so promising for scientific study is like finding a diamond in a pile the size of Mount Everest. A diamond that might contain secrets about life itself. In the grand scheme of the universe, Proxima b is a complex object that provides us with priceless hints that may completely alter our perception of habitability and extraterrestrial life. The scientific community is intrigued by Proxima b's proximity to Earth, as well as the intriguing hints suggesting that this planet may actually be Earth 2.0. Proxima b is well situated in what astronomers refer to as its parent star's habitable zone, where the temperature is just right for liquid water to exist. Think waterfalls, wandering rivers, huge lakes, and maybe even seas as deep and enigmatic as the Mariana Trench. But let's first talk about some of the anomalies before we begin daydreaming about taking a trip to Proxima b. Imagine sunrises that not only herald a new day but also unfold slowly, refusing to give way to midday, and sunsets that stretch out, producing golden hours that photographers dream about. A single day on this fascinating exoplanet lasts an astounding 11 Earth days. Although it sounds beautiful, there are important ramifications for the climate and habitability of the area. It seems as though nature is posing a riddle wrapped in a conundrum, testing our comprehension of what makes a planet habitable. You may wonder how we can obtain accurate and reliable data about a world we have never visited. How would human biorhythms adapt to the cycles of light and dark on Proxima b? Would we need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way in this very different world? The fundamental patterns of life as we know it would be at once tantalizingly similar and startlingly strange. The James Webb Space Telescope uses all of its powers like a Swiss Army knife in space. Thanks to cutting-edge technology, astronomers can now conduct comprehensive research in space using advanced spectrographs, which are more than just telescopes. These instruments allow astronomers to not only detect planets but also analyze them using sophisticated analytical techniques that would make CSI labs appear archaic. These far-off planets' light emissions and reflections can be examined via the Webb telescope. Studying these patterns will help scientists understand how each element or compound in a planet's atmosphere absorbs or emits light at a particular wavelength. By remotely examining celestial planets, scientists are able to ascertain not only the density and atmospheric pressure but also whether organic molecules, oxygen and water, compounds necessary for life, may exist there. This is not only astronomy but also space forensics. Instead of waiting for clues to present themselves to us,